In section 2.6, we're proving statements about segments and angles. We're moving a little bit further onto what we did yesterday, looking at proofs, specifically two-column proofs today. Remember that a proof is any logical argument to show that something is true. We can use definitions, postulates, properties, theorems, all for reasons in that proof. Because remember, we have our statements and then we have to always give a reason or explain why something is true in a two-column proof. These are the types of things that you can use as those reasons. Definition would be like the definition of a term or a word. Postulates, remember, are those kind of accepted statements. Properties, and theorem is a statement that can be proven. And we're going to have theorems throughout the entire year that you're going to be given or that we are going to prove because a theorem can be proven. So working with two-column proofs today, remember that you put a line across the top and splitting into two columns where we have statements and reasons, and we number those statements and reasons. Starting out with something we did last section, we talked about these three properties: reflexive, symmetric, and transitive properties of equality. Well, those work for equality, meaning things being equal, but they also work for congruence. Theorem 2.1 tells us that congruence of segments is reflexive, symmetric, and transitive. Theorem 2.2 tells us that congruence of angles is reflexive, symmetric, and transitive. All this is saying is that those properties work for segments and angles. Remember that reflexive property said that something was equal to itself. Here we're talking congruence, so maybe a segment is congruent to itself, like segment AB is congruent to segment AB. The reason? Reflexive property of congruency. So instead of POE for property of equality, these will be POC because it's property of congruency. Symmetric, remember you think symmetry and you think kind of a reflection or like flipping over in this case, congruent sign. Let's do this with angles. So let's say I know angle A is congruent to angle B. Actually, I should be saying if angle A is congruent to angle B, then symmetric means I can reverse the way I wrote that, look at the symmetry of it, and say angle B is congruent to angle A. And finally, transitive property of congruence could be, again, with segments or angles. Both of these work for either. So transitive property would be if, let's do with segments. Let's say we know segment AB is congruent to segment CD. And I also know that I'm going to use segment CD again, because remember transitive property, you think train or chain rule. So if AB is congruent to CD and CD, that segment is congruent to segment EF, then your final statement using transitive property would be that starting at the beginning, segment AB is congruent to, and I go right to the end, because both AB and EF are congruent to the same thing. We're congruent to CD, so they're congruent to each other. So really, these are just saying that reflexive, symmetric, and transitive property work for congruency of segments and angles, and so you'd use property of congruency POC instead of PO, because these are not equal sign, they're congruent sign. Quick example with that then, name the properties shown. If you knew that angle RST was congruent to angle MNP, then the angle MNP is congruent to angle RST. Notice what happened here is we switched the order that they were written with the congruent sign, and that is your symmetric property, because you're thinking symmetry, so you're thinking flip the way they were written. And again, instead of PO, it's POC, property of congruency, because we're doing congruent signs between. In example 2, if we knew that segment AB was congruent to segment FG and segment FG was congruent to segment MN, then segment AB is congruent to segment MN. Notice segment FG is congruent to both AB and MN, so then I know AB and MN are congruent to each other. This is that transitive property. Think about that train or chain. And again, since we're talking with congruent signs instead of equal, I would do POC, POC, property of congruency. All right. Let's get to something fun here. Do our first proof for today. I want to prove this property of midpoints. So we're proving a statement that we already know to be true here, but using a very formal step-by-step two-column proof. So, this property of midpoints. If you know that M is the midpoint of segment AB, prove that AB is 2 times AM, and AM is 1/2 of AB. So I wrote a few things here, and kind of a hint. We're not given anything here. I need to identify what's given. I need to identify what I need to prove, and definitely draw a picture. So I think I'm actually going to start with my picture. Notice how it said M was the midpoint of segment AB. So there's my segment, and I'll label point A and B there. And I know that M is the midpoint of AB, of that segment. Now remember what that means to be a midpoint. When we start the proof, we're gonna get something even from the word midpoint, because it definitely tells us something about this segment here. Alright, so I have to identify what was given and what I need to prove. What am I given? It says you know that, so that must be what I'm given. You know that M is the midpoint of segment AB. So I'm given M is the midpoint of segment AB. I'm going to identify what I need to prove. Let's see, prove that AB is 2 times AM and AM is 1/2 of AB. So it looks like I'm proving two things. AB is 2 times AM. Prove. I'm going to write out exactly what I'm seeing. AB is, what symbol stands for is equals, right? AB is 2 times AM. So that'd be 2 times AM. And also prove AM is 1/2 of AB. AM is or equals 1/2 of or times AB. So those two things I have to prove. Let's set up my 2-column proof. So first of all, I'll kind of set up the 2 columns. And remember, with this formal proof, you do statements and reasons. And then I will need to number these. Move those up a bit. Oops. Okay. I always start with what I'm given, and I need to rewrite this. I was given M is the midpoint of AB. Of segment AB. And again, that was given. Alright, where am I going from here? If M is the midpoint of segment AB, I'm trying to prove that AB equals 2 times AM. AB is the whole thing. Is that really 2 times this length of AM? And you should be thinking, yes, that makes sense. Based on this word alone, midpoint, what does that tell you? What does the word midpoint tell you? Well, if M is the midpoint of segment AB, don't you know that AM is congruent to MB? Because the midpoint is in the middle. It divides that segment into 2 congruent segments. It also is called the bisector of that segment. So I guess from that word, I could write down what I know. I know that AM is congruent to MB. And I have to put the segments over here. That's what I know, is that AM is congruent to MB. How did I know that? Because of the word midpoint. Now, anytime you're getting info from a word, it must be because that's the definition of that word. So my reason here, definition of, and I'm going to abbreviate definition, and that's fine. But that's the definition of the word midpoint, is that it divides a segment into 2 congruent segments. AM has to be congruent to MB then, because of that word. Alright, what else do I know? Well, I got from the word midpoint that those segments are congruent, but somehow I have to prove that 2 times AM is AB. I know AM and MB are congruent. How am I going to prove that this length of AB is twice this length? One of the only other things you can do, now you know if you have a segment that's broken up into 2 smaller segments, you can add the 2 parts of the 2 smaller segments to get the whole thing. That's where I'm going to have to go next here. Oh, and actually, before I do that, notice that I have equal signs here, and right now I have congruent. There's a little distinction to be made. Now, we know when we say segments, they have to be congruent, but if I want to talk about lengths and eventually say things are equal, you're going to have to go to equal sign here. So instead of segments being congruent, I want that these lengths of these segments are equal. And you can go from congruent to equals anytime by definition of congruence. That's something we're doing for the first time right now. Anytime you want to go back and forth between equals for segments and congruence for segments, you just say definition of congruent or definition of congruent segments. Alright, now we'll do that step I was talking about before. Sorry about that. We know that this big segment AB is made up of AM and MB together, and you know that when you have a large segment, you can add the two smaller to get the full segment. So I know that I can do AM plus MB, add those together, because those two parts give me the full segment of AB. And what allows you to add two smaller segments to get a larger is segment addition. That's always a good one to use. And now, remember that I'm trying to show that AB is 2 times of AM? AB is 1 AM, but hey, AM plus MB, what do you know about AM and MB? They're exactly the same. So I'm looking here and I'm thinking, well, if AM is the same as MB, instead of MB, I could put another AM. Remember that you want 2 AMs. So instead of AM plus MB, I know that MB is the same as AM. I'm going to put that in because I know they're equal, and what allows you to put one thing for another if they are equal is substitution. Property of equality. And at this point, what's AM plus AM? Isn't that 2AM equals AB? AM plus AM, all I'm doing here is combining like terms, because AM plus AM is 2AM. And now I've proved the first one, that AB is 2 times AM. Technically I should switch these around, but that's okay. And finally, the last thing is I want AM as half of AB. Well, 2AM is equal to AB. If I want to have half of AB here and I want just AM, I could divide both sides by 2 and get that AM is 1/2 of AB. What allows you to divide by 2 on both sides of an equation? That is division, property of equality. Division PO, because I'm dividing by 2 on both sides. Alright, so proving a property of midpoints here, and I actually had to prove 2 different statements there. Okay. Oops. So again, I had to use the definition of the word midpoint to say that these 2 segments were congruent. Anything that's congruent is also equal by definition of congruence. I used segment addition to add the 2 smaller to get the larger segment, and I substituted MB for AM because I knew they were the same, combined like terms. We're good to go. Alright, one more proof today. The distance from the park to the pool is the same as the distance from your house to the school. The school is between the pool and the house. Prove that the distance from the park to the school is the same as the distance from the pool to your house. Assume these are all on the same line. Wow, that got a little bit complex. I might start out, remember it said distance from park to pool is the same as the distance from your house to the school? I know I'm gonna need a picture. So you know what, I knew there are 2 congruent lengths. So I'm just gonna copy and paste real quick here and label these. Park to the pool, maybe we'll call park K, and then we'll call pool just P. So park to pool is the same as the distance from your house, call it H, to the school, call it S, and I'm going to put tick marks on those because they told me that the distances were the same, meaning those segments are congruent or the lengths are equal. And now they said the school is between the pool and the house. Oh, you know what? I was going to say I can move this, and remember how they're all on the same line, so I'm going to have to put these on the same line here. The school's between the pool and the house. This was my pool. I'm going to have to switch H and S here, so that the school really is between the pool and the house. And they're all on the same line, so we'll get this to work here. And I don't think I know any sort of relationship here between distances from the pool to the school, so. Alright. I'm going to group this all together, and I think that looks good. Let's check this again. Distance from the park to the pool is the same as the distance from your house to the school. Park to the pool is the same as distance from your house to the school, marked with congruence symbols. The school is between the pool and the house. Prove that the distance, okay, here's what I'm trying to prove. Prove the distance from the park to the school, remember park was K, to the school, is the same as the distance from your pool, from the pool to your house. Alrighty. Well, I did the disappearing ones, but take a look here. I'm going to do this with a real pen. Park to school is the same as the distance from the pool to the house. If we know that these portions are congruent, then this is congruent to this, and the only thing that they have in common is right here. They both have that in common, and we already know that these two are congruent. So really all it is that both of these congruent segments are adding this segment PS to them. We should be able to prove this because all you're doing is adding that segment in the middle, that PS. Alrighty. So I'm going to set up my 2-column proof, identify my given and prove, and we're good to go. So statements and reasons. Setting up my formal 2-column proof. I'm going to identify my given real quick and my prove. Now I was given that park to pool, which we called park K to pool, so KP, that distance, is the same as or equal to the house to the school. And I'm trying to prove that distance from the park to the school, which would be KS, right? Park to school is the same as the distance from the pool to your house. Pool to house. Alright. Okay. Remember, this is what we're trying to prove congruent. We don't know yet, but park to school is the same as pool to house. So we're trying to show that that is true. Alright, first thing, you start with your given. KP equals HS. Definitely given. And there are a lot of ways to go about this proof. I might start there. Remember how with KP and HS, all we have to do to get the segments that we want to prove congruent KS and PH is add this segment PS to both of them. Now actually, I can take that first thing where I had KP is equal to HS, and I can add PS to both of them, because you can always add something to both sides of an equation. What allows you to add something on both sides? Well, I'm adding the same thing on both sides of an equation. That's addition PO, just addition property of equality. But why is that helpful? Remember how we're trying to show that KS is congruent to PH? Well, maybe I should talk about KS. Because KS is a longer segment that's made up of two smaller segments. To get KS, I know that I could add these two segments together. I could add KP, I could add KP and PS, because KP plus PS would give me KS. Notice, I have KP plus PS right here. That's the same as KS. Also, I'm going to do this before I give my reason, because I know in a similar fashion I can talk about segment PH being two smaller ones, PS and SH. So that segment PH, pool to the house, that I'm trying to prove congruent to KS is, I'm going to write it this way, SH plus PS. Or actually, HS plus PS, because I wrote it that way right here. Now both of these are allowed because I added two smaller segments to get a larger segment. That is segment addition. And segment addition here. Again, all I did was realize that these segments were made up of two smaller segments, right? KS was really KP and PS combined, and PH was really HS and PS combined. Now here's the deal. I go to this step. Remember, we're trying to prove KS and PH were the same? KP plus PS is right here. And what do I know that KP plus PS is equal to? KS. And remember how HS plus PS is right here? And what do I know that HS plus PS is equal to? pH. So now I'm basically done. Instead of KP plus PS, I can put what it equals, which is KS, equal to, instead of HS plus PS, I can put what HS plus PS equals. When I add those two segments, I get the bigger segment, pH. And the park to the school is the same as the pool to the house. That's what I was trying to prove all along. Well, actually, what did I do on this step? Instead of one thing, I wrote another that it was equal to. Anytime you put one thing for another when they are equal, you are substituting. So this is substitution. Okay. So some more proofs with segments and angles. Talking a little bit about reflexive, symmetric, and transitive property.